Welcome back, everyone. Couple of quick announcements. This is up on Quarkus, but the logic lab locations are as such. So don't frantically write this down. It's in the slides. It's on Quarkus, but here we are. Exercise 3 is now up. So it's just 10 derivations. And I've moved on the basis of a request from a student, which seemed reasonable to me, I've moved the due date from Friday at 4 p.m. to Saturday at 4 p.m. But I want you to note that this is a trap. This is a trap for you, because the reason why it was on Friday at 4 p.m. is because there was going to be somebody present, either keeping an eye on the discussion board on Quarkus or running a logic lab on Friday or that kind of thing. So if you wait until 2 p.m. on Saturday to start this, there's not going to be anybody around to help you necessarily. Maybe some generous soul will respond to questions on the Quarkus discussion board, but I'm not going to guarantee that me or the TAs are going to be paying attention to what's going on online on our Saturday afternoon. So you get an extra 24 hours, but it's a trap. Okay? So I recommend you act as though the due date was 4 p.m. on Friday, and then you'll have help available up to the very last minute, which isn't actually the last minute. Does that sound all right? The worry was that people have classes all week and you don't have time to do these exercises, but so this gives you another 24 hours to work on this stuff. Okay, so just quickly to point out a couple things here. So you can see it's all derivations. The first two are from the last section. The first two are not using the new connectives that we've talked about, but they do involve writing a show line. I'm going to start today's lecture by talking a little bit more about writing show lines. The rest of them will involve the new connectives. I'm going to teach you today the rules for dealing with these new connectives, but none of these involve the skills we're going to learn on Wednesday. So as of the end of today's lecture, you'll have all of the tools necessary to solve all of these. Okay? So today we're going to do the rules for the new connectives. On Wednesday, we're going to learn a couple of derived rules. We'll add a few more rules. Next week, I'll give you exercises using those derived rules. Next week is Thanksgiving, so there's no class on Monday. You can be thankful for not having to learn more logic. And then we'll do truth tables, and then the next week after that is the test. So today and tomorrow are the last sort of derivation skills we're going to learn before the test. We're not going to learn any new symbolization skills. There's this thing with truth tables you have to learn, but basically this week is like, other than truth tables, everything you need to know before the test. Okay? And I'm getting very reasonable questions about what the test is going to look like. And here is an answer. So for the derivations at least, here's the answer. I've put up on Quarkus blank derivation pages that are exactly what the derivation pages are going to look like on your test. So they look like this. Show the following argument is valid using a derivation. Use only basic rules. So you'll have a list of the rules that you're allowed to use, and that's it. And then just a bunch of blank lines. Okay? I'm not going to give you a chart of what the rules are. You have to know the rules. But I'll give you these cues to remind you which rules there are. Okay? And you're going to have to write your own numbers, and you're going to write on these tests. So what I recommend when you're practicing this stuff is the following. You're doing your exercises on Logic 2010. Look at the exercise, look at the question, and just write it in up here. Write the question in, and then try to solve it by hand. Because you've seen me struggle with derivations in this class, and you might think, well, I don't think this guy can do logic. But I can. I swear I can. I passed this class, and then I was a TA for like 3 semesters. I can do logic. But what I'm having to do is relearn it in a new context that is in front of you fine folks. So what I don't want for you is to have to go through the same process on the test. So if you've learned how to do all your derivations on Logic 2010, and then you sit down to write them out by hand, it's a learning process. It's a transfer process. It's cognitive work in order to transfer the skills that you've learned in Logic 2010 to pen and paper. And you don't want to be doing that work on the test, right? That's a bad place. That's a bad time and place to be doing a bunch of extra mental effort, right? So if you've only ever practiced on Logic 2010, you're going to sit down on the test and be like, I know how to do logic. So that's bad, and I don't want that to happen to you. The way that you can solve that is by printing off a bunch of these sheets and practice doing derivations on these sheets. This is exactly what it'll look like. Pick a favorite pen that you're going to use, pen or pencil that you're going to use, so you get the context of training to be as similar as possible to the context where you have to perform. That's how we're going to minimize, that's how we're going to maximize the test's diagnosticity of how well you know logic versus how well you can remember what Logic 2010 looks like and translate that onto a page. Okay? So there's one for basic rules. There's one also for derived rules, which we'll learn on Wednesday. So this is what I'd recommend. Practice derivations on these sheets. Print off a bunch of these sheets and practice on pen and paper. And then if you get it pen and paper, then type it into Logic 2010 and see if it works. Okay? Okay. So there'll be a bunch of derivations on the test. They'll look like this. There'll be a bunch of symbolizations. They'll just look like a sentence and then some atomics, and you're going to build that sentence and logic out of those atomics. And there'll be a truth table, which we'll talk about next week, and then a couple of short answer questions on validity, and that'll be the test. Okay, so I'll talk more about that as we get closer, but that's up on Quarkus. Use those so that you don't get into the test and find that you've forgot, despite knowing how to do a derivation, you've suddenly forgotten how to do a derivation, because that is what will happen if you don't do some pen and paper practice. Okay? Okay. So I want to start by doing something I've mentioned this. I want to do this one more time with a couple of examples so that you really get this, because this is one of the trickier parts of doing derivations. So getting unstuck in a derivation often involves writing a new show line, your own show line, which you can do at any point without any justification. You can generate a new show line, and then if it's a conditional, you start a conditional derivation, which means you get to assume something that you can use. Or if it's not a conditional, you can start an indirect derivation, which means you assume the opposite, which you can then use. Right? So you can always give yourself options by writing a new show line. However, it doesn't always make sense to just write any random show line. So you have to, and it's kind of an art to figure out when it's the right time to write a show line. You have to pick something that looks like it would be useful, and you have to pick something that you think you can show. Okay, so I want to do a couple of quick derivations that involve this, just to show you. I mean, I think the practice of it is probably the best way to understand it. So we're going to show, if not P, then Q. Okay. Okay, so we're going to look around. In any derivation, we're going to look around. What have we got? See if we can make some automatic moves. I mean, oh, sorry. This is I'm going to show a conditional, so we're going to, of course, start a conditional derivation, not P. We're going to assume for conditional derivation, and then we're going to show Q. And why not? We can assume not Q for indirect derivation. Okay. So we've got not P, we've got not Q. I mean, there isn't a heck of a lot we can do. So we can do a couple of things. We've got not Q, which is the negation of this conditional. So we can say line 4 and premise 2, modus tollens. It's not premise T. There's no such thing as premise T. Modus tollens, which gives us not S. Okay, so S, that's pretty good. We could have also said S if we said double negation after this, if you want to save yourself a line. Okay, so now we got S. We could get the negation of this thing. We could get the negation of this conditional, but that's not going to do us much good in this case. So, I mean, I'll write it out just for the sake of having done everything that we can do. R not S, so that's line 2, premise 1, modus tollens. Oh. Okay. Does anybody else see anything obvious to do here? Obvious moves that you can make? Like not really, right? There's not really much, in terms of just using what you've got, there's nothing you can do here. You're stuck. You're stuck in your derivation. So you're sitting there, you're in the test, you're sweating, you're thinking about your life choices. Oh God, oh God, oh God, what do I do, what do I do, what do I do? Okay, so now you've done, so this was all just pretty straightforward automatic moves, the forward-looking strategy where you're like, what have I got and what can I do with it? And now we're stuck. And now we have to get ourselves unstuck. We need to show something. These are the conditions under which it's probably a good idea to start thinking about what it would be nice to have. What would be useful in this derivation to have? Well, look at premise 1. If I had, if r then s, that would give me p. And p would give me the negation of this, which is a contradiction, which would give us this indirect derivation, which would give us this conditional derivation. So man, it would be really nice to have if r then s, right? That would be a useful thing to have here. We've got not r then s. That doesn't do us much good, though. So it would be nice to have if r then s. So I'm going to write myself a new show line. Show if r then s. And notice I don't write anything here. Just like in my other two show lines, I don't write anything to justify this show line because I haven't claimed anything yet. I haven't said I have anything. I haven't claimed to have proven if r then s. I'm just saying, you know what it would be nice to get? If r then s. Okay? And now this is a conditional, so I can give myself r. We're going to assume that for conditional derivation. And I want to show s. So if I can show, on the assumption that r, if I can show s, then I've shown if r then s. And then I can use it to do other stuff. OK, now for the very challenging task of showing s. Well, I got s. Where I got s? Line 5. So I say line 5, repeat, direct derivation. So I just said, yeah, I'm going to bring that into my subderivation. I used repeat because I'm closing this off. And now I can say I showed s. Cool. Well, now that I've showed s on the assumption that r, notice I didn't use the assumption that r. I didn't use that at all, but I nonetheless had s already. So if this said show x then s, I could have done the exact same thing, right? Because given that I have s, if anything, then s follows. So I've shown this. So on line 9, I did my conditional derivation, box and cancel. OK? Now I've shown if r then s. There's two ways I could end this. There's a couple ways I could end this now. Yeah?
On line 6, in the justification, since you're saying 2, do you want me to put r there as well because you're bringing not p down from the subderivation?
No. So in this case, so the question is, don't I have to say 2 repeat? We talked about this briefly at the beginning of last class where I'm not going to require you to say repeat unless you're doing one of these direct derivation, conditional derivation, or indirect derivation, because that's what Logic 2010 does. If you're just using the line in making an inference, you don't have to use repeat. Yeah. That was a change from how I first presented it, because I thought Logic 2010 always required it, but I was wrong. So OK. So now how do we end this now? Now we've got a thing. We wrote ourselves a show line. Now we've got a thing. There's at least 2 ways we can end this. Yeah?
You already have a contradiction.
Right. 6 and 7 is a contradiction. So I could just say 6, 7, indirect derivation. And I don't have to say repeat because these are both in the same subderivation. And then I can say, look, I showed on the assumption that not q, I showed a contradiction. Therefore, I've shown q. Yeah? One other way we could have ended this was to say we've got if R then S, and then we can say premise. So on line 7, premise 1, modus ponens gives us P. And then now we've got another contradiction, so we can say line 2, repeat line 12, indirect derivation. That would also give us this. And then, of course, we just finish it off. Line 14, line 3 was our conditional derivation. Box and cancel. OK. So the point of that was the show line got us unstuck. We had no resources. There was no ability to make any more moves. And then all we did was ask ourselves, what would be helpful here? What would get me unstuck? If I had it, what would get me unstuck? OK? OK, let's do one more example. I'm doing a lot of this because it's a really crucial skill, and it's one of the less intuitive skills. So it's not automatic is the problem. A lot of the moves we're going to make are just automatic. You just learn, if I see this, then I do this. But writing a show line, you have to kind of be able to look at where you are, understand the flow of the proof, and like see where you want to get. So you have to do both of the perspectives. You have to do both the forward-looking and backward-looking kind of at the same time. OK. So once again, let's go into this naively. OK, show not P. All right, well, that's not a conditional, so I'm going to assume the opposite for indirect derivation, just because I'm never going to get in trouble doing that. OK, so let's see. What can I do with not P? Well, I can give myself the negation of this big weird thing. So I can get if not Q, then S by doing line 2, premise 1, modus tollens. OK, cool. Can't really see anything I'm going to be able to do with this. This will be more useful once we have derived rules, because we can do a negation of this. But anyway, but for now, given just doing basic rules, so far we got not P, we got this big weird thing, and we've got these. Again. So what now? OK, so this is going to happen to you in your general life as well. So imagine that the conclusion P is a happy, fulfilled, flourishing life. OK? The conclusion P is your life going well. And you made all of the moves that were required of you. You did what your family wanted. You met society's expectations. And somehow you're still stuck, unable to get to your flourishing, happy life. You're stuck. You did everything that they asked you to, and you're stuck. Well, what would the existentialists say we should do? What would Nietzsche say we should do? Nietzsche would say, this is Nietzsche's favorite move in a derivation, is writing your own show line. Nietzsche should say, you need to set your own goal. You need to create for yourself a goal that is unexpected, is not one that was given to you by the automatic moves of your society. You need to generate your own goal. And that'll liberate resources and energy for you that you can move forward in your life and get to that P, which is, of course, a happy, fulfilled life. OK, so this is what we're going to do. And you can't just make up any goal for yourself, right? You can't just be like, I'm going to ride the unicycle, and then you'll have a good life. Like, that's not how it works, right? You need to pick a goal that makes sense in your context. You need to pick a goal that A, will get you something that you want, and B, that maybe you could achieve, right? You don't have to know exactly how you're going to achieve it when you set the goal, but you do have to, have some hope of showing it. So if I said show X here, nothing to do with X. None of my resources are related to X, so that's not a good thing for me to try to show. What you want to show is something that would get you somewhere. So I think here, if I had if not Q, then S, that would be good, right? That would get me P, which is the goal I'm trying to get, right? Okay, so let's try that. Let's try show, oh, sorry. I'm going to write me a show line, making Nietzsche happy. Show not Q then S. Again, you don't have to justify your goals to anybody. Why is it you want to do that? I feel like it. Okay, this is a conditional, so we can give ourselves not Q. We're going to assume that for conditional derivation. And now we need to show S. And we can give ourselves not S. We're going to assume that for indirect derivation. Again, if we just get directly to S, that's fine. We just say we'll do a mixed derivation. We just say, yeah, we got S. Okay, now we've got some stuff. Now we've got at least two more things that we can use in this derivation, right? So we can do, for example, we can do something with these two premises. These are premises that we couldn't interact with before. We had nothing to do with them. But now that we've set our own goal of showing not Q then S, we've made a couple of assumptions. Now we can use these. So for example, not Q and modus tollens will give us this. So we say on line 5, that's premise 2, modus tollens, and I'll double negate it so we get rid of the double negation. So not Q gives us R. It would have given us not R, but I double negated it, so that gives us R. Cool. If R then S, well, geez, now I've got it. I've got the thing that look what I can do. So if I use line 8 and premise 3, modus tollens, or modus ponens, I get S. Now I've generated a contradiction with S and not S. So in line 10, we say line 9, or line 7, line 9, indirect derivation. I've shown S. And now I've done on line 6, I've done my conditional derivation. So I got this. Okay. Okay, so now I've got not Q, therefore S. And again, I could end this in two different ways. I did this, I got this, which is the negation of this, so I could do 3, 4 indirect derivation. I can also say, if not Q, then S, so I've got that now. Now, because I've shown this thing that I set out to show, I can use it to do stuff. I can use it on premise 1, so line 4, premise 1, modus ponens, giving me P. And in this case, P was the thing I set out to prove all along. So I can just say line 12, direct derivation. Done. Quickly notice that I started off on an indirect derivation, right? And then I ended with a direct derivation, but that's fine. This is what's called a mixed derivation. So I didn't need to write this assume for ID. Did I ever use line 2? No, I never. Yeah. Well, I used it to get this thing, but then I didn't use this thing. So I could have skipped these two lines. I could have jumped straight into show not Q then S. But I did them anyway to just sort of get myself fully and properly stuck, to see if there's anything that I could do with what I've got. And then I decided, okay, well, this has got me nowhere, so now I'm just going to show this thing. And I was able to show this thing. Okay? Yeah?
Will we lose marks in the test if we have like unnecessary bits in the derivation?
No. Good question. Do you lose marks if you have unnecessary parts? The answer is no. Because I got to my goal by following all the rules here. There's no extra points for doing, like a really experienced logician can do really nice, clean, tight proofs on a very minimum number of lines, but that is not a skill. That's like an aesthetic skill over and above this. So if you get to the conclusion by following all the rules, you get all the marks. Yeah?
And would you ever be asking us to do a mixed derivation or not in the mixed derivation, or would you do it for one?
I'll never specify what type of derivation we want. It will just be derive this, and however you get there is fine. So if you had done this as an indirect derivation rather than a direct derivation, that would be fine. Here we did a mixed derivation. We started one kind and ended with another. That's fine. Okay? Okay. So that was writing your own show line. Recall that I said these weekly exercises, the first two you're going to have to write your own show line. There's a video on Quarkus. If you don't know how to do that on Logic 2010, there's a video on the Quarkus showing you the controls. Basically, instead of writing in the middle column, you write in the left-hand column. It's not too challenging. Okay. So questions about, okay, so that was writing your own show line. So we did the examples. A couple of caveats, things not to write show lines for, and I hope this sounds obvious, but I guarantee you people do this on the regular. People write show lines for premises. Show this premise. And that's just basically confused, right? Because you have the premises. You don't need to show the premises, you have them. Similarly, for any available line, an available line is something that you have. You don't need to show it. So if you go off trying to show a line that you've already got or a premise, it just shows that you don't really understand how the proofs work, right? Because you don't want to show something you've got you're just wasting time and energy, right? It's not technically wrong to try to show something you've got. You can do a very quick show line to get something that you've already got, but once you've boxed it off, you can't use the content anymore. So you really just wasted time. So keep in mind, you want to show something that you want, not something that you have. Yeah? Okay. Questions about writing show lines? Like, this is the least automatic part of writing a proof, in my opinion. It's the part that requires the most understanding of the larger structure of a proof, right? It's a part that requires you to say, oh, geez, where am I in this proof, and where do I want to be? It takes some insight. Just like setting your own goals in life, it will take some insight and some courage, because you may or may not know how you're going to show that thing when you write the show line. So, yeah.
So, on your other show there, you had.
Do you want to? Here.
Last one that you did.
Yep.
The one, yeah. So like line 4, you say show not Q as, which
Yeah.
is one of the premises, but that's okay.
No.
Right below it.
That is not one of the premises.
Oh, that's right, because it's and then not.
Not Q, then S, then P is the premise. So that's what you've got, which is not the same as knowing that not Q, if not Q, then S is true. Yeah? So knowing that you're given the conditional, you show the antecedent. Another thing that you might have tried to do here is show the negation of one of the consequents. Right? So if I decided, I might have been able to solve this by trying to show not P. No, I've assumed not P for indirect derivation. So that wouldn't have gotten me very far. Maybe not Q. If I decided to show not Q, that might have helped. Maybe. Okay. So yeah. If I'd written show if not Q, then S, then P, then I would have just wasted my time. It would have done nothing for me, because I have that already. I can use that as many times and as many places as I want. Okay. So writing show lines. Keep this in mind, practice it. When you get stuck, remember that this is always there. It is always an option to write yourself a new show line, and writing a show line unlocks things that you can use to make moves. Okay. If that's enough of that, let's move on to conjunction, disjunction, and biconditionals in derivations. So, last time we introduced these 3 new connectives, and we talked about, I showed you their truth tables, and we talked a little bit about what they mean in terms of symbolizing them. Now we're going to introduce 2 new rules associated with each of them. So we got 6 new rules, meaning we've gone from 4 rules to 10. We've more than doubled the number of available rules. So we really are substantially ramping up the complexity of the derivations that we're going to do, and we're going to continue to ramp it up until you hate me in this class in your life. That's pretty much the plan for the rest of the semester. It's not as bad as all that, because it's not the case that these new rules will just apply anywhere. You'll know when they're relevant because they apply to a given connective. So, talk about conjunction first. So recall this is the truth table for conjunction. It's true just in case both of the things are true. I show you this so you can understand why the rules work. So there'll be two rules that make sense given this. So simplification. Simplification. If you've got the following conjunction, box and circle, you can get box. And if you've got box and circle, you can get circle. Right? Because box and circle is only true if both box and circle are true. Yeah? So this makes a conjunction a really nice thing to have. Conjunction is rich in implications because you get both halves of it and you can use them independently. You cannot use them independently until you've simplified them apart, however. So you can't just, if you've got box and circle, you can't just cite that and say, well, since I've got circle, I can do this. You have to simplify them apart, okay? Here is the simplest derivation that I could think of using this rule. So show P given P and Q. We simplify premise 1 S, and then we did it. Okay? Low stress. Hopefully that doesn't stress you out looking at that. Okay, simplify. Just to note, so there's a slight difference between how we're going to do this in written form and Logic 2010, because Logic 2010 doesn't know, if you just write premise 1 simplify, it doesn't know which side you want. So you can shorten things by, you write simplify left, SL. So I'm not going to require you to write SL or SR on your test. So if you write this thing on the right here, that's just fine. Okay? Logic 2010 will demand that you do this. It will demand that you show it, you tell it which half of it, because it doesn't know which half you want. Okay? So far, so good? Good. Okay. Now, that was what to do if you have a conjunction. What if you want a conjunction? What if you're looking to show one? Well, if you've got box and you've got circle, then you can get box and circle, right? Again, this should be obvious from thinking about the truth table. If they're both true, the conjunction is true. And that's an adjunction. You adjoin them. To adjoin, to put together. Adjunction, ADJ. Okay? And of course, having box and having circle will give you either box and circle or circle and box. You can get either. Again, the simplest possible derivation using this. I've got P, I've got Q, I want to show P and Q, premise 1, premise 2, adjoin, the end. I don't think I'm actually going to, I don't think showing you these derivations teaches you anything. I just want to reduce your panic level at seeing these rules in derivations. I think that's really, there's a more of an emotional function to these than anything. Okay. So again, in Logic 2010, it'll ask you which order you want them adjoined in. So a little pop-up will come up and ask you, hey, which order do you want these in? When you're doing derivations by hand, you just put them in the order. You just say ADJ and just put them in the order you want them in. Because this is just to like a little tease to remind you that you're a human who can do things insightfully. Just to give you the flavor of it so that the bitterness of not having that the rest of the time is more salient. I think that's why it's like that. Okay. Okay. And do note that the order matters. The order in which these things happen does matter. So having box and circle, if it's box and circle, therefore P, and you have circle and box, that doesn't get you P. Why is that? Because we're so picky. Because we're being so picky, super duper picky. So the order does matter. If you've got, for example, Q and P, and you want P and Q, here's what you've got to do. It's not hard, but you have to do this. You have to simplify them apart and then put them back together again in the order that you want them. Yeah? Premise 1, simplify. If it was Logic 2010, I would say premise 1, simplify right to get P. Premise 2, simplify. That's not premise 2. Premise 1. Okay. Also premise 1, simplify. And then we put so we've just taken our premise 1, taken it apart into its parts, and then put them back together in the order that we wanted. Okay? Okay. Okay, so that was the 2 rules for conjunction. If you're going to take a conjunction apart, you use simplify. If you're going to put one together, you use adjoin. Now let's do disjunction. I think I don't have to explain why those rules work, right? If those rules are mysterious to you, talk to me and we will work it out. Okay, so here's 2 rules for disjunction, for the or function. Right? And we recall this is true in any case where either one is true or both are true. The disjunction comes out as true, and false only if both are false. Okay? Okay. So addition. This is a lovely rule. I love this rule. If you got box, you can get any box or circle. No matter what circle is. Circle doesn't have to appear anywhere in the proof. Circle can be literally anything that you want. So if I've got P, I can derive P or literally anything. Why does that make sense? Because having the truth of one of the conjuncts or disjuncts guarantees that the whole disjunction is true. If I know box is true, then I know box or anything is still going to be true. Right? Okay. So here's me. This is slightly less than the most simple possible version, but here's it in action. So I want to show P or this weird, big, funky thing. Okay, P or weird, big, funky thing, and I've got Q, and if Q, then P. So I derive myself P. So I can't just say, I'm just going to make this up. You can't just make up a disjunction, right, out of thin air. You need 1/2 of it. So on line 2, I've derived half of it. And now, given half of it, I can just add on the other half. You just add it on. Tack it on there. And then you're done. Yeah? It feels liberating somehow. It feels nice to be like, I can add anything I want. You can, if you're feeling constrained in a derivation, you can just add a bunch of stuff just for the pure liberty of it. It doesn't get you anything because you can't get anything out of it, but you can do it just to express yourself if you want. Okay. Okay. So addition. Again, in Logic 2010, it'll ask you what order you want to add the so if you say add, a little pop-up will come up and say, in what order do you want to add the disjuncts? And then it'll ask you what new disjunct you want to add. Once again, deriving by hand, you just add whatever you want in whatever order you want. Yeah. Okay? Okay, and here's why that add thing was okay. Here's why that made sense. Well, here's part of why. To get something out of a disjunction, you need the following. You need the negation of 1/2. So if I know that box or circle is true, and I know that box is false, what's the only condition under which those two things can be true? If circle is true. So circle was doing the work there. Circle was giving us the truth of that sentence. Right? Box is not carrying its weight. Box isn't helping. Circle did it. Okay, then I know. If I know that box is not carrying its weight, it's not helping, then I know it's circle that's doing the job. So circle comes out. And of course the other way as well. Modus tollendo ponens, or MTP. Yeah? Is it obvious why that works? Okay. Nobody's willing to stick up their hand and say, no, this is totally not obvious to me. Please explain. Okay. Okay. Another one, again, not quite the shortest possible one, but again, a very short derivation. Show that v is true, and we've got not p and not x. So we got this disjunction, and we've got not p, and we've got not x. Well, given that p is false, I know this thing must be doing the making it true work, right? So this whole thing can be true while p is false under only one condition, that this conjunction is true. So I can get out of premise 1 and premise 2, modus tollendo ponens, I get v or x. And now I want to get v. I know that v was doing the work all along because x is false, right? The negation of x is true, therefore x is false. So v, modus tollendo ponens. Yeah? Yeah.
Can you just go over the example?
Yeah, yeah. Okay, so we've got three things. We've got this triple disjunction, and that we've got that two of them are false, right? Two parts of this disjunction we're given as premises are false. That is, not p is true. Anytime you say a premise, the premise is always true, right? We'll assume the premise is true. So if not p is true, that means p must be false. Given that p is false, given the negation of one half of the disjunction, you get to infer that the other half is true. So you get that, right? So that's what we've done in step 2. We said premise 1 and premise 2. Given that p is false, I can infer that this half is true, right? As a whole sentence. The whole sentence has got to be true. Now, given that that whole sentence is true, but also one of its disjuncts is false, that is negation x is true, so I know that this isn't doing the work of making this whole sentence true. That means I know that v must be true. And that was the thing I was trying to prove, so I'm done. Okay. Good. And once again, just to be super picky, we're going to require, so not p, sorry, p is not the negation of not p. Not p is the negation of not p. Again, because these circle and square, so this is just to show you, you have to do premise 2 double negation, and then you can use that to modus tollendo ponens. Because again, these circles and squares they are complex sentences, and these rules only apply to the major connective, the main connective of the sentence. So in this case, the main connective of this sentence is not right? So we need the negation of something. So the negation of this. Okay? Okay. One last set of rules for the biconditional. So recall the biconditional, it's like adding two conditionals together, if p then q, and if q then p. And it ends up with this truth table. So p and q are either both true together or both false together. And then the biconditional is false in any other circumstances. Okay. So biconditional is also a really nice thing to have. If you've got a biconditional, you can get two conditionals out of it. You pull these conditionals out of it. You have to do this before you can do anything with the biconditional, really. You need to say, oh, I've got box, biconditional, circle. Well, then I can get if box, then circle. Similarly, from the same thing, you can get if circle, then box, right? Because the biconditional is just saying the conditional goes both ways. You can use biconditional to conditional to get the conditional out of it. And then you can do stuff with the conditional. Yeah? So if I've got p biconditional q and p, I'm not actually allowed to say premise 1 modus ponens with premise 2. Right? I have to extract the conditional out of it first. Yeah?
Don't you also
Why would you need to do that? No, I don't have to prove the biconditional. I have the biconditional. I'm given the biconditional as a premise.
But it's saying that if P then Q and then if Q then P, so that's what it's saying.
That's right. So the biconditional says if P then Q and if Q then P.
Yeah, but here we only prove that if P then Q.
Well, we only needed one half. Well, we only needed one half of it to get through this proof,
Oh,
right? You don't always have to extract both directions of the biconditional out. In this case, all we needed to get Q, given that we've got P, all we needed to get Q was if P then Q. So I only pulled one half of the biconditional out of it. Yeah. Okay? So given a biconditional, you get conditionals in both directions if you want them. Okay? So nice to have a biconditional. Always nice to have one because you get two things out of it. Again, in Logic 2010, it'll ask you which side of the conditional you want. And when you're writing by hand, again, a little glimmer of humanity and insight, you just write the direction that you want. Okay? Finally, so our last rule that we'll introduce, we'll take a break and we'll do some examples. Conditional to biconditional. So if you want to get a biconditional, what you need are both halves. You need box, then circle, and circle, then box. If you've got both of those things, you use conditional to biconditional, and you get either direction of the biconditional. Yeah? So really quickly, so I had to, in this case, I forced myself to derive both sides of the conditional. So given x, so I've got x as premise 3, and then I just modus ponens myself, P then Q, and then modus ponens myself, Q then P, and on 2, 3, I did conditional to biconditional, CB. And that was what I was looking for, so we're done. Okay? Okay. And once again, it'll ask, driving by hand, you do it how you want. And once again, order matters. So if I was to derive if Q then Q biconditional P from P biconditional Q, just like with and, I just take it apart. So premise 1, biconditional to conditional, pull out if P then Q. Premise 1, again, biconditional to conditional, pull out the other direction, and then put them back together in the order that I want. Okay? Okay. Let's take 10 minutes, come back at 11:10, and we'll do a bunch of examples. So what I propose to do for the rest of this class is just examples of this stuff. I think the best way to learn this stuff is just to see it in action. So I'm just going to work through a few derivations that will start off pretty straightforward, but to use these rules in derivations. So this is from Logic 2010, 2.00b. So as always, we start with our show line. So we're going to show Q and not T. Okay, so typically I've been telling you the assume for indirect, anything but a conditional assume for indirect derivation is the automatic move here. I'll make that move just to sort of keep it consistent. So not Q and not T. Assume for indirect derivation. But I'm going to tell you now that that line is going to be useless to us. We're not going to be able to do anything with that line yet. Later on, on Wednesday, we'll learn some derived rules, which make this potentially a useful line. But right now, it's just useless to me. But I will assume ID just to keep the habit up. So basically, what we're going to have to do, you've got Q and not T. We're just going to set about trying to show both halves of this and then adjoin them together. So we've basically got a 2-for-1 derivation special today, show Q and show not T, and then put them together and we're done. So we'll end up with a direct derivation. This is going to be true anytime you're trying to show a conjunction. Probably you're going to have to show both halves of it and then just put them together. So We just set about trying to show one or the other of them. So let's try to show not t, shall we? So t shows up here. That's a place t shows up. So if I had the negation of this, I could get not t by modus ponens, and hey, I have it. Hooray. It's almost as though somebody set this up so that I could succeed. So premise 2, premise 1, or sorry, premise 3, modus tollens gives us not t. All right, halfway there. Okay, now I'm going to just set about trying to show the other half. Try to show q. Q and not t, so I'm going to try to show q. Well, what have I got? Where is q? Here it is. It's in a disjunction. How do I pry something out of a disjunction? If I want one of the disjuncts, I can't, like with the conjunction, I can just simplify them apart. Disjunction, you can't do that because you don't know, just based on the fact that P or Q is true, you don't know that Q is true. You don't know that. It could be false and P is true, and this whole thing would still be true. So we need the negation of the other half, right? Which, hooray! Once again, the gods have smiled on us, and we have the negation of the other half. So we say premise 1 and premise 2 this time. Remember the name for this? MTP. It sounds like something a cell would produce, doesn't it? Modus tollendo ponens. So the negation of one half of it gives us the other half. Great. Now we've derived the two halves of this thing. We got q and not t. So I'm just going to put them together. Q and not t. Line 3, line 4, A, D, J. I joined them together. Yeah? Yeah?
Do you need to say line 4, line 3, ADJ?
No, you don't. Yeah, so the question is, do you have to get them in the right order? No, you don't. No, you don't. You can just, because you're intelligent people, you can adjoin them in their correct order for your purposes.
And if we do have the line 3, that's still fine.
Sorry?
Right 4, 3, ADJ.
That's right. So if you'd written for 3 ADJ, that would be fine too. What's going to happen in Logic 2010 when you write this line is that it's going to ask you what order you want them in. A little drop-down menu will pop up, and you have to click the one that you want. But when you're writing this by hand, you just write it in the order that you want. Okay, and that's it. We're done. So on line 5, we did our direct derivation. Cancel and box. Once again, we did a mixed derivation here. So we started off with the automatic move of assume ID. We didn't use that at all. We didn't prove a contradiction. We just proved the thing that we set out to show in the first place. So this is not an indirect derivation. It's a direct derivation. Once again, a mixed derivation is fine. You start off with one thing. You start off, I'm sorry to keep bringing this back to life lessons, but like in life, if you start off trying to do one thing and you ended up at your goal anyway, that's fine, right? You ended up at your goal, right? So don't be a stickler for how you planned things to go. Just if you get where you're going, you got there. Yeah.
Would 2.5 indirect derivation also finish the proof?
That's right. Very good. So if instead of doing a direct derivation, because we did this ID and because these two lines contradict, we could have said 2, 5, ID. And that would have been, this is a uniform derivation. It's not a direct derivation because we ended it the same way we started it, assumed for ID, and then did an ID. That would equally well have been, so exactly as many points for either of those. Okay? It's good. Okay, let's do another one. Right. So, once again, we're going to show a conjunction, not Q and T. I'll spoil the ending for you and just do a direct derivation. I think this one works on a, yeah, this one will work on a direct derivation too. So I'll just try to do this directly. Okay, so what have I got? here, let's just do the forward-looking thing for a moment and say, what moves have I got? We've got a couple of moves that we can make. Actually, we've got several moves that we can make. We've got a bunch of resources here. So take a look at premise 1. Now, recall, so what's the, oh, geez, all right, well, what's the major connective here? Yeah, the biconditional. This is our major connective on the basis of our blatant favoritism for conditionals and biconditionals. That if it doesn't say which one's the major connective, then the conditional or biconditional gets the major connective. So if I was doing this, if I was going to do more carefully, it would look like this. Right? So P biconditional, if not Q and S. Okay? So let's just pull these, I mean, just for the sake of it, without thinking about strategy or where we're trying to go, let's just unpack what we've got in these premises. So premise 1, biconditional to conditional, gives us a couple things. It gives us if P, then not Q and S. And you can use it again, premise 1, biconditional. You don't use it up. You can use it as many times as you want. Not Q and S, therefore P. You didn't have to write these brackets. I write them because it helps me visually to chunk it. I'm like, OK, that's a chunk and that's a chunk. Yeah? OK. Cool. OK, so this is just unpacking premise 1. So we've unpacked this. Now we've got a couple of conditionals that we could do things with. Now, premise 2. We can also unpack this thing. It's a conjunction. It's two things. It's 2 for 1 special, again, on this premise. So we can get P from premise 2 simplify. And just for the sake of completeness, we can also get if not T, then not S from premise 2 simplify. OK. OK, so all we've done so far is just unpack the resources that we've got. Right? We've taken these 2 premises that we were given, and we just sort of pulled apart what they give us in terms of resources. So now we've got 4 available lines to work with. OK. So now we look at our available lines and ask what we can do. I mean, so maybe a quick backwards looking is appropriate perhaps at this point. After you've finished the moves that seem obvious and automatic, it's often a good idea to take a moment and reflect on where you're trying to get. So where we're trying to get here is, again, not Q and T. We're just going to try to show both sides of this and then put it together, just like in the last proof. So, OK, so not Q appears in this premise, right? And we unpack that into this thing. So if I had P, I can get both of these. Because inside here, this conjunction gives me both of those. It's easy to get not Q from not Q and S. So if I got P, then I can get not Q in 2 steps. So that's good. That's good. Because we've got P, right? We simplified that off premise 2. So if I say line 2 and line 4, modus ponens, then I get not Q and S. That's good, right? And now we get not Q by just, it's more Q than I was looking for, from just line 6 simplified. You see how we got there? Like, now, notice that this side of the biconditional is not doing much for us here. I unpacked it just for the sake of completeness, just to have it. So if I had not P, then I could have gotten this thing. If I'd ended up with not P somehow, that would have been all right. OK. Now, we've got 1/2 of this. Remember what we're trying to show? We're trying to show not Q and T. We're just trying to show both sides and then put them together, and we got 1/2. Good. Making progress. Now we just need T. So we poke around and see what lines we've got. Where does T show up? Well, it shows up here. OK, good. But how do I get T out of if not T, then not S? Yeah. 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 And furthermore, that's right, so we're going to do line 6, simplify again to get the other half. And in this case, because I know I'm about to use this in a modus tollens, I'll say double negate, and I'm going to get myself not S. Yeah? And now I can use not S in line 5 and do a modus tollens. So you say line 8, line 5, modus tollens, which gives me not T. If I wanted to save even more space, I could have said line 8, line 5 modus tollens, double negate, to give myself T. You don't have to do this stuff where we're packing a bunch of stuff into one line. If you prefer to just have it all laid out, that's fine too. But yeah.
You have to write line 8 out as not S, or can you just write S?
It's got to be not S. So the question is, did we have to do that double negation? And yes, again you do, because we're doing modus tollens on, like, so this is, to make this messy, this is our box and this is our circle. So to do modus tollens on this, you have to have the negation of the circle. And the negation of the circle is not S. It's not S. Yeah? So when you're looking at how you're allowed to apply the rules, the reason why we do this, when you're looking at how to apply the rules, you kind of have to ignore everything within the, like, everything within the circle is like a mysterious black box to you. There's just nothing, you don't know what's in there, it's just a thing. And in this case, if you used S and modus tollens this, you're kind of like, oh, I know what's in the mysterious black box here, right? And I know that if I double negated this, then I would have gotten that. So again, for the sake of acting not unintelligently, but without inspiration or insight, we do not S. Okay? Okay, so now we've got our two halves. We were trying to show not Q and T. We showed not Q. We showed T. So now we can get not Q and T by line 7, line 9, adjoin, ADJ, and then we're done. So line 10 is our direct derivation. Cancel and box. Yeah? Yeah.
Biconditional is our main connective because it's a leftmost one, or because it's a
Because it's a conditional. The question is, why is the biconditional the main connective there? Even if it had been in the other order, the biconditional would still be the main connective, because we are blatantly favoriting the conditionals and biconditionals if it's not clear. Yeah. Yeah. Okay. Questions before I move on? Okay, let's move on. Right. So, show S, which is, of course, a happy and flourishing life. That's what S means. Just remember that. All right. We'll assume not S for indirect derivation. Okay. I'm doing it this time. I'm doing the assume ID, and it's more likely to be helpful to me because this is a really simple thing that probably will be able to plug in here somewhere. Okay. So once again, survey our resources. Let's see what we got. What do we got? What moves are just going to be simple, straightforward unpacking of what we've got kind of rules or moves? Yeah.
Premise 2, modus tollens.
No, not modus tollens. Modus tollens is when you have a conditional, right? Furthermore, you need two things for modus tollens.
Premise 2 is a conditional.
Premise 2 is a conjunction.
Or 3, sorry.
Premise 3, modus tollens. You could do that. You could do that. So you get the negation of this whole thing. So if we say premise 3 and line 2, you get P, not P or Q and, Q and T. I'm going to admit, modus tollens. I don't have a good feeling about this as a thing that we're going to use. I don't have a good feeling about this. I don't think this is going to be super helpful. But you should take it. That doesn't mean that you shouldn't do that move, because you don't know, right? Unless you can see the way to the end. If you can see the way to the end of the derivation already when you start, that's awesome. Just make the moves that you need, that you know you need. If you don't know what you're doing, it's perfectly good strategy to just do whatever's available to you. Just try stuff, see what happens. You don't know, maybe it'll help. Okay. Another thing that we could do, however, is on premise 2, we could just simplify that apart. Premise 2, simplify, give ourselves not R. I should be indenting here. Similarly, we get T. Premise 2, simplify. Okay. So, yeah.
I just had a question for
Yeah.
the conditional, the main connective.
That's right. The conditional is the main connective. Once again, on the principle of blatant favoritism for conditionals and biconditionals. So notice it's ambiguous, right? There's this P or this thing, then S. And a reasonable person might think that what it means is P or this conditional, right? That doesn't, I don't know an in-principle argument for why that's not how you could read it, but other than because I said so. It's not an in-principle argument other than on the principle that I'm allowed to do that kind of thing. But given the rules that we said, we're going to blatantly favor the conditionals as a main connective. That means this sentence gets parsed up like this. Yeah? Which is why we were allowed to do not S, therefore not this thing. Yeah? Okay, good. Okay, so we've got 4 available lines. We've got a premise that we haven't done anything with. So we haven't done anything with premise 1. Here's another sort of strategy that you can ask yourself. What haven't I used yet? So you've got what is it obvious that I could use, and you've also got what haven't I used. The fact is, I'm not going to give you derivations to do with like 5 totally useless premises. I'm just not going to do that to you. It's conceivable that somebody could do that to you. So you just got tons of premises and you don't know which ones are useful. I'm not going to do that to you. Okay, so if you haven't used something, there's a good chance it's useful somehow, and you should try to figure out how you can use it. So on that basis, premise 1, oh, I haven't done anything with premise 1 yet. Is there anything I can do with that? Yeah.
MTP was line 4.
Exactly. So we'll say premise 1 and line 4, modus tollendo ponens. So you see not R, the negation of 1/2 of this. We know this is true. It's a premise, so we know that it's true. We're going to assume that it's true. And if we know that 1/2 of it is false, that means we know the other half must be doing the work. So we know P must be true. All right. So now we got 5 available lines. That's pretty good. Now, what can we do now? Yeah.
Can you add the Q and T?
Q and T. We don't have.
P. So because it's a disjunct.
You can add. Oh, I see. That's right. Yeah. So if we wanted to have. Oh no, sorry. Q and T. No, we can't have Q and T.
You can't add the thingy.
Can you be more specific than thingy?
Sorry. I think one of the examples that you showed for anything that you could add on to the side of a disjunct, you could just do that
Good.
thing in the parentheses. So
Very good.
Q and T could be added as the
Sorry.
disjunct of P.
Okay, yes, I didn't understand your first time, but that is exactly right. So what we're going to do here is, because this thing is a disjunction, and I've got 1/2 of it, I thought you were saying, can you just add Q and T together? So you can't. So here's what I thought she meant, which would be wrong. You cannot do this. Because I've got T, you cannot say Q and T add, because I haven't got Q. That is wrong. Okay, but here's what she's saying, which is the correct answer. What we want, or what we've got is P. That means that we can get P or Q and T by just saying line 6, add it on there. We can help ourselves to or Q and T because we've got P. Remember that you can add anything you want. So long as you've got 1/2, you can add anything else to the other side of the or statement. Yeah? And why did we do that? Why was that a clever thing to do? Yeah. That's it. That's it. So on line 7 and premise 3, we can do a modus ponens, giving us, ta-da, S. That thing that we were looking for all along. Happiness and flourishing. Right? So line 8, we did a direct derivation. Yeah?
ID works for that too?
ID would also work. You could have done line 2, line 8, ID. Yeah. Yeah. Anytime you've got a contradiction, you can do ID. Yeah?
Is it necessary to show that addition? Like,
To show which?
so we, on line 7 there,
Yeah.
we added Q and T
Yeah.
to P.
Yeah.
But we know via our logical rules that P could also just end up with S, given the nature of the disjunct. So is it necessary to do that addition, or?
The answer is yes. The answer is yes for the exact same reason as why we had to do the double negation before. Because, again, so here's the rule for addition. For the conditional, right? The rule for the conditional is this, and you've got this. If I want to do modus ponens, I need this, right? Now, this is the antecedent of the conditional. This whole thing is the antecedent, and that it's clear to you that you can get this whole thing from just P is good. That means you can solve the derivation. That's good for you as a human. But it's not good for us in terms of the derivation. It's not good enough to just know that you could get this. You have to show me how you got it. Because it's like you're skipping a step in the derivation, and the very nature of a derivation is to skip no steps. We skip no steps. That's how you show that you got, in a very mechanical way, from premises to conclusion. There's no gaps in the argument. So in this case, you do have to do this. You do have to say, I've got P. Well, now I'm going to get the antecedent of this by adding this on. I'm telling you which rule I used to get that. And now I've got the antecedent, and now I can use modus ponens on this. So the reason why this rule exists is to keep you only ever making the tiniest possible steps, right? That's how a proof proceeds, by the tiniest possible steps, one thing and then the next. Yeah. Okay? Yeah.
So in line 8, would I have been able to, instead of saying S, say line 3, line 7, some direct derivation?
Oh, yeah, you would have. You would have. Good. It wasn't useless after all. I'm sorry. Look at that. So if I'd said, I maligned line 3 unfairly. Line 3 had a perfectly good role. We could have done this in fewer lines. Because look what this is. The negation of this thing. So what she's saying is, why can't I do this? And the answer is, you could. You could. And there's our indirect derivation. Very good. Yeah. Poor line. I apologize to line 3. Okay. Good. Good. Okay. Another. Unless there's more questions about this? Yeah.
For line 7, you see how it says 6 add?
Yeah.
How do we know that you're adding that part of the premise 3?
So there might be two questions. How do you know to do this? Or how do you know that that's what's happening?
Yeah, yeah.
You don't have to look at P3. You don't have to look at P3.
So you can just add any.
You can add literally anything. It does not have to appear in the proof at all. Yeah. Now, that's a weird and silly thing to do. It nonetheless follows the rules. Like, you don't want to just add anything because you're just wasting your time. Again, you're trying to imagine yourself in the test. You're sweating. Your stomach is upset. You know. So you don't want to make moves that don't get you to your goals, but you're perfectly able to add anything here. So line 6, add whatever you want. The marker will look at that and say, yeah, you're allowed to add whatever you want. No problem. In this case, we added something useful. But yeah.
So for premise 1 there,
Yeah.
what if premise 1 was not P or not R?
So.
How would you be able to get either side?
So if it was not P or not R, you could get not R, and that would give you not P. Or you could get not P, and that will give you not R. Yeah? It's a good question. Yeah. Okay. Another. Is this the last one? Oh, yeah. This is one. This is going to be long. I'm going to do this. I'm probably going to do this on Logic 2010 if it's OK with. No. Well, OK, actually, do you want to see it on Logic 2010, or do you want to see me do it by hand? By hand. OK. All right. All right. You're mean. All right. OK. So I'm probably going to have to do like 2 rows in order to get this done. OK. We're going to show this biconditional. OK. OK. So remember our rules for the biconditional. How do you get a biconditional? There's only one rule that you can use to get a biconditional. Yeah. That's right. You have to show both directions of the conditional. So in this case, I mean, I'm going to skip, for brevity, I'm going to skip the standard assume ID and just say, look, I'm just going to show first if P then not Q and R. And I'm going to show this. And then once I've shown this, I'm going to show if not Q and R, then P, just the exact opposite direction. And then put them together, and we'll be done. So it's sometimes helpful if you want to like sketch out for yourself the basic structure of your argument. It's going to go like this. Yeah? So I want to show this. So I'm going to do that and then put them together with conditional to biconditional. So that's our plan. You do have to have some sense of your plan. Once the derivations get long enough, you do have to have some kind of plan for attacking them. The kind of plan that you want is based on what you're trying to show. In this case, we're showing a biconditional, so we want to show both halves of the biconditional. The nice thing about that is it's a conditional derivation, so we get to start ourselves, so we can we give ourselves P. We're going to assume for conditional derivation. Actually, I have to delete all this because I'm going to need this space, sadly. Actually, so we'll just remember, here's the plan. Therefore, box biconditional. OK. So give ourselves P. We're going to assume that for conditional derivation and try to show on the basis of P, show not Q and R. Good. So once again, we're going to try to show a conjunction, which basically means you're going to have to show both sides of this thing. You could, once again, you could do an assume ID. I'll skip it because I don't think I need it. Because I don't think I can, at this point, I don't think I can use the negation of this conjunction. But you could do that if you wanted. All right. Now just start looking around and asking myself, what have I got? What do I need? One thing that I've got is premise 1 here. OK, let's unpack that. So unpack that into if Q, then not P from premise 1, biconditional to conditional. These are, the BC and CB are fairly easy to remember. You start from what have I got to where am I going? I'm starting from a biconditional, going to a conditional, B, C. Okay.
Would it be possible to just simplify premise 2 and then have like not Q and then R?
No,
No?
no, because this is
Because that's a condition.
this is a conditional. Yeah, you cannot simplify a conditional. Yeah. Okay. So let's make some moves. So I've got on line 3. If I double negate that, I can do line 5 a modus tollens. So P, I double negated P to got not P, and then not P is the negation of the consequent. So I get the negation of the antecedent. So I get not Q. Hey, that's pretty good. That's one of the two things I was trying to show. Hooray! Okay, how do I get R? Yeah,
Line 6, premise 2, modus ponens.
exactly. So not only was that one half of the thing I was trying to show, it's also super useful for getting the other half. So on line 6 and premise 2, I'm doing a modus ponens. That gives me R. Great. Now I've got not Q and R. I got not Q, I got R. That means that I can on line 6, 7 adjoin. And hey, that's the thing I was trying to show. Hooray for me. Yay, me. So line 9, we say on line 8, we did a direct derivation. Hooray! Whew. Okay. Take a minute. Remember what I'm doing and where I'm trying to get. So, okay, so I showed this thing. What of it? Who cares? Oh, well, I was trying to show this thing as part of a conditional derivation. Oh, yeah. Okay, that went well. So that means that on line 4, I did my conditional derivation. So on the assumption that P, I showed not Q and R. Very good. So cancel and box. Whew, okay, great. Life is going well. I'm achieving my goals. So I did 1/2. So thinking back to the overall structure, hooray, I did that part. Yeah? Now I have to do the other half. I have to do show the other direction. Remember, I'm trying to show this biconditional. So what I need to do is the other half, and then I'll be done. So write myself a new show line. Once again, you have to be responsible for setting your own goals in this derivation. Not P. Okay, so you see how this is the other half, right? So if P, then this thing. If this thing, then P. So far, so good, yeah? Okay. This is going to get hectic. Okay. Right. And once again, I'm trying to show a conditional, so I just start myself a conditional derivation. I can assume, this is a nice thing to get to assume, Q and not R, and assume this for conditional derivation. And now I need to show on that basis P. Cool. And I might as well give myself not P, assume that for indirect derivation. Okay. Good. Okay. Is that? This is why I wanted to do it in Logic 2010, but you guys are mean, so. Okay. So, now keep in mind, I've started this new show line, I've started a conditional derivation, I've started an indirect derivation. None of this is available for use. I could use this line. So line 2 is available for use. That's the only line I have available. So all I've got right now is line 2, which I can't see how I could use it because I don't have P and I don't have the negation of this thing. All I've got really is line 12, line 14, and my premises. Yeah? Yeah. No. No, I do not have line 4 because line 4 is within a canceled show line. So putting this box around this, so this is the result of a subderivation, but because I've put this box around it, that's my indication that I can't use line 4. Yeah? I can't even pull it out using repeat. Line 4 is like in a little mini universe. We're like, oh, imagine that P is true, and then do I get this thing as a result? But now we're done imagining that P is true. We don't have that P is true, actually. Right? We no longer have that. We were imagining it was true and seeing if the consequent followed. But now we've finished that. We have to box it off and say, OK, we're no longer imagining that. So that means that line 4 is not available. Line 2 is available because it's not part of I haven't like boxed it off. Right? OK. OK. So where are we? What's going on? I'm just going to start fresh up on line 15. OK. So, but I still got my premises. You know, that's nice. And line 12 is nice as well, right? Line 12 gives us at least 2 things. So let's unpack line 12. We got not Q from line 12 simplify. And we've got R from line 12 simplify. OK, so we got a few things. We got not P, we got not Q, we got R. That's not bad. Do something. Hopefully we'll be able to do something. We're just trying to show P or generate a contradiction. OK. And we can once again unpack this thing. So in this case, I'll just do both directions just for the sake of being kind of mindless about it. This is premise 1. Premise 1, biconditional, 2 conditional. We got not P, then Q. Premise 1, biconditional to conditional. OK. OK. Yeah.
Line 19.
Thank you. Line 19. OK. Yeah.
On line 14, could we just do a 12S PR2
Sorry, 12S PR2 modus ponens? Yeah, yeah. So we can do that. We can, instead of, oh yeah, so, well, we simplified already, so that, well, I'll just use this. But, so, premise 2, line 15, modus ponens. That gives us R. We had R already, though, so maybe I'll leave that one out. But you could have done that, yeah. I saw a hand? Yeah.
For line 15,
Yeah.
would you have to show a repeat to bring line 12 down?
No, no, you don't have to do repeat because this is not, we're not closing off this derivation. So you use repeat on if you're writing a direct derivation or indirect derivation or conditional derivation, and you're using something from outside your subderivation, then you have to use repeat. But if you're just using the line and it's an available line, you don't have to. OK, good. OK, so what do we got here?
Do 14 and 18 modus ponens?
Very good. So we've got not P. We've got if not P, then Q. So on line 14, line 18, modus ponens, giving us Q. Well, that's looking hopeful.
15 and 19,
Perfect, because Q and not Q, 15, 19, ID. So I'm going to box this off. And where did we start here? Oh, yeah, we started here. So we've shown P, and we've shown P on the basis of if, or not Q and R. So what we've done on line 13 is a conditional derivation. Box that off. Okay. Okay, we're almost done. We did that bit. Yeah? So we showed one half, and we wrote ourselves a fresh show line, showed the other half. Now all we have to do is put them together, and we're done. Yeah? Okay, so that's line 2, where we showed one half, line 11, where we showed the other half, and we're going to make two conditionals into a biconditional, which in this case is, and again, we're smart people, we can just put it in the order we want, not, Q, and R. Line 23, line 22, direct derivation. Ta-da! Bam. Easy, right? Oh, there's no problem. This is not easy. This is getting hard. This is genuinely getting hard. The hard parts are remembering all the rules and remembering where you are in the derivation, right? What currently am I trying to do and why? So there's a whole bunch of stuff you need to keep track of. But if you can keep track of those things, you know, this is not too terrible. If you can remember the rules, remember how they apply, and figure out when to apply them, I guess that's all of derivation. So just know how to do derivations, and then you know how to do derivations, which is clearly a valid inference. OK. Quick questions before we're done? Yeah?
What should we write all lines underneath? We can't see it, the rightmost part.
Sorry, I can't hear you.
We can't see the rightmost part on screen.
Oh. Oh, I'm sorry. This stupid screen. OK, yeah, sorry. On YouTube, this will look fine. Yeah. There you go. Conditional derivation. Oh, conditional to biconditional. Sorry, CB. Conditional to biconditional. That's where we put those two halves together. OK, that's it for today. Thanks.